This is a video on the homework review for Chapter 3.2, which is on measures of center for stats. So let's go ahead and get started. I'm just going to try to do all these problems here just so that you have some reference to check your own work and see if you're on the right track when doing these. So number 11 asks us to find the mean, median, and mode and mid-range of the set of data, and then asks us a little bit of an analysis question at the end. So these are the thorax length in millimeters of male fruit flies. So let's go ahead and sort of do the standard fare first. So the mean, remember it's x bar. That is when you take all these values, you add them together, boom, and then you divide by the number of numbers there are. So if we add all these together, let's see here, if I bring out my calculator, we add up, let's do this, 0.72 plus 0.9, 0.90 if you want, plus 0.84 plus 0.68 plus 0.84 again, plus 0.9 again, just going through this here, 0.92, 0.84, making sure I don't type any numbers. You can laugh at me if I do, that's fine, I won't hear you anyway. Okay, and then lastly, 0.76. We get 88.88, and then we divide by my count. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we end up getting 0.807 repeating, or 727 repeating. So we'll round that off to about 0.81. Actually, let's just do 0.807 just to be super accurate. Okay, 0.807. In fact, I'll do this. Boom. That's super accurate there. So that's the average. Okay, not too bad. The median, mode, and mid-range. Let's do the mode first. So the mode is easier to do. If you look at here, the mode, I think the most common number is 0.84 because it occurs 4 times in this list. So that would be 0.84. And the median, by the way, the symbol for the median is this little x tilde. That's median, so a squiggle above it. For the median, you'd put all these in order and then find the middle number. To save some time, I'm not actually going to write these in order just because I don't want the video to be too terribly long for those of you with short attention spans. So I'm just going to tell you that when you put them in order and find the middle, it ends up being 0.840. 840. If you can't figure that out, you can let me know and I will talk about that to you directly. But if you put these in order and find the middle, it should come out to be 0.84. And then the mid-range, remember, is just the biggest minus the smallest divided by 2. That's range, by the way. So the smallest number here I see is 0.64, it looks like. So 0.64. Minimum plus maximum would be 0.92, actually, 0.92. And then divided by 2. And so if we calculate this real quick, 0.64 plus 0.92, whoops, 0.92 divided by 2. Come on, there we go. We get 0.78 as my mid-range. And then the last part asks us if we learn that the listed measurements are obtained from fruit flies hovering over an apple in Ponticello, does this serve as a reasonable estimate for all fruit flies residing in the United States? And again, you have to kind of do your justification here. In my opinion, it probably would not be representative of the entire population of the United States just because, again, you're taking it from a small subset. So if you're just taking it from apples in a local kitchen, that's not necessarily going to be representative of all of the United States. So again, this would probably not be a good representative sample. The way they took the sample might not be bad, I mean, because they are taking fruit flies randomly. But if you're going to do a estimate for all of the United States, you want a sample from all of the United States, not just in one area of the world. So again, your sample needs to be more focused, or not more focused, I guess. Your sample needs to be more representative of the population you're trying to assess than it is right here. So also, you can see that the mean, mode, and median, so these right here, they're a little bit skewed. So the mean is quite a bit lower in millimeter standards than the mode and the median. So this is not quite a normal set of data. Not that that has any impact on anything, but just as a note there that this is probably not the most normal looking data because the mean is a little bit lower than the mode or the median, although we'd have to kind of do a histogram graphing sort of thing to make sure. All right, so this one here, this is number 13, got cut off there. So these are the lengths of words. So these are the first 20 words in the tin roof, and these are the first 20 words in the cat in the hat. And once again, they want us to find the mean and the median, not the mid-range, and then compare. Okay, so for cat on a hot tin roof, we're going to add and then divide by 20. So let's go ahead and add these real quick. It shouldn't take too long. Let's see, 2 plus 6 plus 2 plus 2 again plus 1. It'd be fun to see if you guys can do this in your head before I finish typing on the calculator. You can challenge yourself that way. Although if you've already done it like you should, then that wouldn't be much of a challenge because you already knew what the numbers are. Let's see here, 2, 4, 2, 3, 8. I'm probably going to mistype a number here, so if I'm really off, then please let me know somewhere at a point in time. I guess I disabled the comments, so you obviously can't comment on this, but uh, just let me know somewhere. 2, 3, 11. Okay, of course there's. Whoops. Boom. 78 and divided by 20, we get 3.9. Well, it seems like I did it correctly there. For Cat in the Hat, 3 plus 3 plus 3 plus 3 plus 5 plus 2 plus 3 more 3's plus a 2 plus a 4 plus 2 2's plus a 3 plus a 2 plus a 3 plus a 5 plus another 3 plus a 4 plus a 4. Alright, so that divided by 20 gives us 3.1. So, and again, the median, I'm not going to bother rewriting these all out in correct order, but the median for both of them ends up being 3. So x tilde here ends up being 3, and x tilde here ends up being 3 if you put them in order. Again, I'm not going to do that myself, but you feel free to do it yourself. I don't know what I was saying there. So these means here, if we're comparing them, the medians are dead on to the same, so that's nice. The means are pretty close together. I mean, if we're talking about the word length, you know, 8/10ths of a letter is not that big of a difference there. So we can say that these are pretty consistent values there, and um, overall, they don't appear that much longer, although, again, that depends on your justification. So I believe that if you're checking your answer in the back of the book, they said that the first book appears to be longer than those in the second. Again, on average, technically they are, but that's a pretty low height there. I mean, if you're a little bit bigger by one word or one letter or so, because assuming these are the lengths of the words, if you're bigger by one letter, that's really not that big of a deal, I would think. But again, just depends on how big a deal you think one letter is. So again, I can see justification for either setup. I would say that it's not that big of a difference. So weather forecast accuracy. So again, these are your first 14 numbers. There's just a weird formatting issue that they put them in kind of table set like this, but that's just because of the format. So once again, we're going to find the mean, the median. So if we look at these numbers here, if we add all them up, being careful of your negatives, which is actually easier to do because they set up this way. So 2 plus 2 plus 0, 0, 0 plus negative 2 plus 8 plus 1. And then we do the other side, negative 3, negative 2, 1, 1, and negative 1. And then, oh, of course, oh, negative 1, and then we're going to divide that by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Divide by 14, 14, and we get negative 0.07, which is a little bit off. Let me check here. I think I mistyped the number 2, 2, negative 2, 1. Oh, I missed the 8. So let me try that again. 2, 2, 0, 0, negative 2, 8, 1, and then I have negative 3, negative 2, 1, 1, and negative 1. There we go. And then divide that by 14. That's better. We get 0.5. So this average ends up being 0.5. For the other one here, if we add them up, so I'm not going to write down the zeros. So plus negative 1, plus negative 3, plus 6, plus... Now here's what I'm going to do to speed this up. 2 and negative 2 cancel out, so I'm just going to not type those. Plus 5, plus negative 2, plus negative 6, plus negative 1, plus negative 9, plus another 6. And then 4 and negative 4 are going to cancel out, so I'm not going to bother writing those. Divide that by 14, and we get negative 0.32, which I think is a little bit off there. I might have missed an... Oh, I had that little symbol there. That's my bad. Let me try this again. I don't need the answer there. That's probably why. Come on. There we go. Let's try this again. That divided by 14. That looks a little bit better. So about negative 0.35 or negative 0.4. Since this was rounded to the nearest tenth, I'm going to round this one to the nearest tenth. So I'm going to say negative 0.4 there just to keep my rounding consistent. Again, if you want the medians, I believe the median for the first one ends up being 0. So x tilde here ends up being 0. X tilde here, I believe when I did it, I got negative 1. So we have to compare. So it says, do the means and medians indicate the temperatures predicted 1 day in advance are more accurate than those predicted 5 days in advance? Well, again, these are the differences, and I would personally say that's not that big of a difference. So on average, when they predict it 1 day ahead of time, they're about half a degree too high. Okay, that's not too bad. When they predict it 5 days ahead of time, they're about a half a degree too low, zero point 0.4, so a little bit less than a half a degree too low. That's also not bad. So I'd say that they have about the same accuracy. They're both either half a degree high or roughly half a degree lower than the actual value, which is not that far off from the actual value, I would say. The medians are a little bit farther apart, but not that big a deal. Like this median is dead on 0, so that means that according to the median, they're almost always accurate when they predict 1 day earlier. And then when you're predicting 5 days earlier, you're about a degree lower, but that's still not that much. So overall, I would say that there's little difference between predicting it 1 day and predicting it 5 days. So one thing you can say here is that based on the averages and the medians, the temperature predicted 5 days before is about as accurate as the temperature when you predict it 1 day ahead of time. Um, so that could be one justification you can say about how well you're doing. And plus, these are pretty low numbers, so you're not off by too much either. So the amount you are off is trivial, essentially. All right, and so this is the wait time one, so number 17. So once again, mean and median. I'm just going to work out the means here. So x bar. Okay. If we work out the means real quick, so 6.5 plus 6.6 plus 6.7 plus 6.8 plus 7.1, 7.3, 7.4. Terribly exciting stuff, I know, but this is just me checking our work. 7, and then triple, actually. Triple, double, sevens. That should be a lucky number there. And then we divide by, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10, and we had getting a wait time of about 7.15 minutes. Okay, 7.15 minutes. That's not too bad. For the other one here, we have 4.2 plus 5, come on, 5.4 plus 5.8. I keep missing that, 5.8. Must need to get my eyes checked. Plus 6.2 plus 6.7. Although I probably should have gotten checked when I started seeing things, but that's neither here nor there yet. There plus 9.3 plus 10. And then we divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10. That also gives me about 7.15, which is pretty darn good. So this median is also 7.15. So the means are pretty much the same. I believe that the median for the first one is about 7.2. So this x tilde is 7.2. And then the median for the second one, I think, is also 7.2, if I remember correctly, or pretty darn close to it. So the idea for this is that, okay, well, according to the mean and the median, these have dead on the same average wait time. So if you go to the Jefferson Valley and if you go to Providence, you're going to wait in line about the same time on average, which is about 7 minutes. Here's the main difference, though, is that Jefferson Valley is a lot more consistent in their average. So you see all these numbers are pretty close together. Whereas for Providence, you have some numbers that are on a pretty low end and some numbers that are on the pretty high end. So if you go to Jefferson Valley, you're more likely to wait at least the average time or more, or a little bit less. Whereas if you go to Providence, you're kind of gambling. Like you might hit it big and wait just a few minutes, or you might get really unlucky and wait a long amount of time. Now on the average, it's going to be about 7 minutes. But again, if you're rushed for time, you make a choice. You either go to Jefferson Valley and play it safe and wait about 7.15 minutes, or go to Providence and see that maybe you get lucky and you get one of the low times, or maybe you get unlucky and you get one of the long times. So that's what we mean by measures of variation and measures of distance. So these have the same measures of center. I should say measures of variation and measure of center. These have the same measures of center, median and mean, but they have very different measures of spread or measures of deviation, which we'll get into tomorrow. Because Jefferson Valley is a lot more consistent with its numbers, whereas Providence is a lot more inconsistent with its numbers. So for 26, what they want you to do is find the estimated mean. So to find the estimated mean, what you do is you find the midpoints of all these data, multiply them, add them, and then divide it by the number of frequency. So first off, let's do the easy one. So 31 plus 1 is 32, 34, 35. So our total frequency is 35. Okay, that's good. But now let's go ahead and find our midpoints. So remember, to find the midpoint, it's the high end, so 0.49, 0.49, plus the low end, which is just 0, divided by 2. To be 0.245, so 0.245, and then we do the same thing for each one. So again, if you want to skip ahead a little bit to after I'm done with this, you can, but I'm going to have to do these out here. 0.745, 5, we have 1 plus 1.49 divided by 2. We get 1.245, 4, 5, and then we get 1.5 plus 1.99, and then divide by 2. Get 1.745, and 2.49 plus 2 divided by 2, 2.245. And then I'm actually doing extra work than I need, but I'll show you why in a second. 5.49. Now, technically speaking, I don't need two of these numbers. I really don't need this number or this number because their frequencies are 0. So they're not really going to be counted anyway. So I can actually just cross them off. And then the other numbers I can just use. So 0.745 times 1 is 0.745. 5.49 times 1 is 5.49. 1.745 times 2 is something that, something that I don't care to do right now. So 1.745 times 2, that would be 3.49. So 3.49, and then the big one up top here. So that's probably where our frequency is going to lie, is somewhere towards the top class there, just because it has such a high amount of them. But we'll see. 7.595, 7.595, and then what we're going to do is we're going to add all these suckers together. So that plus 0.745 plus 3.49 plus 5.49, and then we're going to divide that not by the number of classes, but by the amount of frequency. So that's going to be 0.49 for that value there, which I think I might have messed up, unfortunately. 31, 32, 33, 34, 35. I might have messed up there because that seems like a little high compared to what I actually have there, because it's a little bit beyond this class, which is weird. Let me write that down here just in case I want to check here. So 0.49. Let me just double check my midpoints. So again, if you're doing this and you think that I'm wrong, you might be right. Let me just check here. Yep, and then 99 plus 0.5 divided by 2. 0.745, that's good. Let's see here. I don't really need this one because it's useless. 1.99 plus 1.5 divided by 2. 1.745, right? And then times that by 2, just make sure my multiplication was correct. 3.49, right? And then 2.99 plus 2.5, plus 2.5 divided by 2, 2.745. Why did I put 5.949? That's weird. I should have caught myself there. That's a silly mistake on Mr. Paul's part. So that's probably why I have such a high number. So that should be 2.745. Some of you are probably screaming at me for that, so I apologize. Then, if we calculate this, this should give us a lot nicer of an answer. So if we go back here, see if I can't go back to, I don't have to enter all these numbers again. See if I get any lucky, or is this going to loop back before I get to there? It's probably going to loop back before I get there. That's unfortunate. Oh, there it is. Good. So if we delete this, or 7.595, so 7, insert 0.595 plus 0.745, and then this right here would be 2.745. And then we divide that by 35. And 0.41, that sounds a little bit more reasonable. 0.416. So again, I did catch my mistake eventually, and that's exactly what you should do when you see that your average is going to be a little bit too high, because this average is squarely inside this first class here, which makes more sense because that has 31 frequencies in it. So unless my average was either this number, these two numbers, or this number, or somewhere close to them, it was probably going to be in this first class. So when I saw 0.49 and saw that it was pretty much on the edge of this class, that seemed a little too high to be right there. So I wanted to go back and check my work, and I found out where I was wrong and adjusted it for. So in truth, I made that mistake on purpose. So we'll go with that saying there, right? We won't think about that too much. So body temperatures. Again, same deal here. You find the midpoints and you multiply. Again, to save you some time, I'm not necessarily going to go through all the multiplication there. I know I'd like to, but I know some of you are probably pulling your hair out at this point. So just to tell you that when you get done with this, your midpoints should end up, or sorry, your average should end up coming out to be 98.17 or thereabouts. Again, if you're like 98.49 or something like that, it means you probably made a minor mistake when doing the midpoint stuff here. So it's not too terribly big a deal, because again, there's just a lot of them. So just be aware. Excuse me. Um, but it should come out to be somewhere around 98.17, and then we wanted to compare that to the value of 98.6. So 98.6 is generally speaking what your temperature should be by medical standards. These people's average temperature estimate was 98.17, which is a fair bit different, because you might say, well, it's just a little bit off. I mean, 0.6 and 0.17, they're not that far apart. Well, that's true, but in this case, a little bit of a change in temperature actually does have quite a big impact on the body. I mean, you figure if you're uh, 1.4 degrees high, you're in the 100-degree territory, and that's when people start to, again, get sick and worry about you there, because that's a dangerous temperature to be at for an extended period of time for your body. So yes, it's a small amount off, but because the body is so sensitive to temperature, that small amount is actually quite a big difference. So this is why that's the difference between this small difference and, if we go back, what was the other one? This small difference. So this small difference in temperature accuracy isn't that big a deal. So a zero point 0.5 degree too high or a negative zero point 0.4 degree too low, that's not very different from each other, because you don't really feel a half a degree too high or half a degree too low. That just doesn't affect you as much out in the open. But if it's inside your body and your temperature changes by that small amount, that can cause some issues. Maybe not in the short term if it gets back quickly, but in the long term, if that temperature change is consistent, that becomes, like I said, problematic. So again, in this case, you could argue either way. You could argue that it's pretty close to the same because it's not that far off in terms of numerical value, or you could argue that it's actually pretty different because even though it's somewhat close numerically, that small difference that's not making up can be quite catastrophic for some people. So again, you can argue both ways as long as you provide justification for it, and your reasoning is sound. So that's it for this video. Again, sorry for the length of it, if it bothered you too much. But I just wanted to go over it. And again, if you want to see me actually work this out, let me know, and I will do a video of me actually working this out, midpoint my midpoint, if you can't get to somewhere close to 98.17. Again, if you got 98.4, 98.5, I wouldn't kick yourself in the butt about it, because that means you probably just did a rounding error somewhere here, or a multiplication error somewhere along there. But if you really want me to do this out by hand, let me know, and I will do that for you. So I just wanted to save you guys some time. Anyway, I'm blathering now. So I hope you enjoyed this video. There'll be another one coming out tomorrow about the next lesson. Please do watch it. Again, I know we're all virtual, but don't think of this as a 4-day weekend. You know who I'm talking about. So just make sure you keep on top of your stuff, both for this class and your other classes. Hope you enjoyed the video. Hope you're having an okay day on Monday. And I look forward to seeing you all again on Wednesday. So have a good day.